Hello again. Today we'll be working in lesson 2-5 where we will be solving for a variable. In this lesson we have two new vocabulary terms, formula and literal equation. We'll go over the definitions of those in a little bit. Our objectives will be to solve a formula for a given variable and to solve an equation in two or more variables for one of the variables. And these two things really pretty much mean the same thing. So let's take a look and see what this is all about. A formula is an equation that states a rule for a relationship among quantities. And there's lots of famous formulas from science class, from geometry class. For example, we're going to work with one later, which is d equals rt, distance equals rate times time. You've probably heard of the Pythagorean theorem, which is a squared plus b squared equals c squared. That's a formula. E equals mc squared. That's a famous formula. Y equals mx plus b. That's a famous formula. So there's a lot of these formulas, and the thing about them is they usually have, but not always, they usually have more than one variable. And that's where our skills for today's lesson are going to come in handy. Our strategy for solving for a variable is really very similar to our strategy for solving for anything. We're going to look for the variable that we're trying to isolate. We're going to figure out the inverse operations that we need and the order that they were applied so we can do them in the reverse order. And we're going to use inverse operations to accomplish this so that we can isolate the variable. So lots of things we've already been doing. We're going to use inverse operations. We're going to isolate a particular variable. It's just that this time there'll be extra letters involved. So why don't we start with an example? There is a formula to convert Fahrenheit temperature to convert Celsius temperature into Fahrenheit. And that's the formula that they've given us right here. F equals 9/5 C plus 32. And what we're asked to do is we're asked to solve this formula for C. So instead of it saying F equals, we want to end up at the bottom with C equals. That's what we're trying to do. We're trying to isolate the variable C. So let's go through our inverse operations and see if we can make this happen. The original formula is F equals 9/5. I'm having trouble writing 9/5. What's going on here? Goodness gracious. There is a weird little mark. Let me erase that. Let's try this again. F equals 9/5. I'm going to put the C in blue because that's the one we're trying to isolate. 9/5 C plus 32. And so what we want to do is the inverse operations in order to isolate C. The first thing you know that I like to do is I like to switch this thing around, right? So that I get my C on the left right away. So I'm going to write 9/5 C plus 32 equals F. Okay? And I'll notice that I have a plus 32 here and I'm multiplying by 9/5. So we're going to run some inverse operations. I'm going to subtract 32 from both sides. And as you know, these cross out. Now over here I'm not going to panic. It says F minus 32, which is math that we can't really do because those aren't like terms. But what I can do is I can just write down F minus 32. Right? F minus 32 is F minus 32, so I write that down there. I'm still left with 9/5 C equals F minus 32. Now we learned a while back that we want to do an inverse operation, and since this is multiplication, I'm going to divide by 9/5, but we don't really divide by 9/5, do we? We multiply by the reciprocal. So I'm going to do times 5/9 on both sides. And we also learned that when you multiply an entire side, you have to multiply all the terms, so we're going to put that in parentheses, and so this is a 5/9 over here. So what we've discovered is that these guys will cross out, that they turn into 1. I'm going to end up with C equals, and then I have the fraction 9/5 times the quantity in parentheses f minus 32, and we're just going to write it just like that. We don't have to do a lot of simplifying when we're solving formulas, right? We started with one formula that had f equals, and we're going to end up with a new formula that has C equals. That's all we're trying to do. So if you know the Fahrenheit for a particular temperature on a particular day, and you want to convert it to Celsius, looks like we have to subtract 32 and then multiply by 5/9 to figure out what the Celsius is. So that's the strategy. We are just isolating variables like we always are. We use inverse operations. It's just that sometimes, like right here, we'll have a variable involved where we won't be able to make a calculation. We simply write it down. Let's take a look at a few other examples. The formula for a person's typing speed is S equals the quantity W minus 10E divided by M. That's a lot of letters. Where S is the speed in words per minute, W is the number of words typed, and E is the number of errors, M is the number of minutes. And what we're asked to do after all of that is we're asked to solve this thing for W. We want to end up with W equals at the bottom, okay? So let's go ahead and write this down. It's S equals, and I'm solving for W. I'm going to put that in blue. W minus 10E over M. Okay, let's get to it. So you know what I'm going to do. Right away I switch this thing around because I want W on the left. I want to isolate W on the left. W minus 10E over M equals S. Remember, this is a rational expression. It's a big fraction. And the way we solve with big fractions is we deal with the division first, because there's parentheses here that are implied. So I'm going to multiply both sides by m to get these m's to take care of each other. And that means that on this side I end up with sm. So I have w minus 10e equals sm. Okay, I'm looking at w minus 10e. I need an inverse operation. That'd be plus 10e. And I have to do it to both sides, just like always. Now, over here, great news. These cross out. I end up with w equals, which is what I was looking for. On the right side, I've got this weird thing, sm plus 10e. I have no idea what that means or how to add it up, but I know how to write it. It's sm plus 10e. And that's all the math we can do. We stop before we get ourselves in trouble, and we call it a formula. We solved for w, which is what they wanted. I have w equals, and if somebody ever tells me what the speed in words per minute are, the number of minutes, or the number of errors, I can calculate this person's words typed. Okay? Again, we're just using inverse operations to isolate the variable that they indicate in the problem. Let's check out some more information. Actually, before I define literal equations for you, let's try one more quick example. The formula for the objects, for an object's final velocity f, is f equals I minus gt, where I is the object's initial velocity and g is the acceleration due to gravity. Time is t. We're supposed to solve for I. Now I got this little shape here because the answer's hidden behind it. And I don't want you to see it ahead of time. So we're solving for I. Right? That's what they've asked us to do. Solve for I. So I'll write down my formula. F equals I. I'm going to put that in blue. Oops. Equals I minus GT. And just like always, I like to get the variable on the left right away. So I'm going to make it I minus gt equals f. You can see right away I need one inverse operation, which is to add gt to both sides. Don't worry what kind of a thing gt is. It's just a product. It's an expression. The thing is we need to add it to both sides so we can isolate I. So on this side I end up with I equals. And over here I have to do whatever this math is, f plus gt. Don't really know what f plus gt is, so I'm just going to write it down. And what I come up with is a formula for I, right? This formula is solved for I, so I have I equals. That's the gist of it. And if I could move this rectangle, which I think I can, sort of, you can see it says I equals f plus gt, which is what I thought. Okay. Now I promised you that definition for literal equation, and here it is. A formula is a type of literal equation. Okay. And then the next sentence tells us what it is. A literal equation is an equation with two or more variables, two or more letters. And to solve it, we simply use inverse operations, right? We're going to solve for one of the variables using inverse operations. That's what we do. That's what we've been doing. Some of these literal equations are formulas, and some of them are just equations with a bunch of letters. But we do the same sort of inverse operations to solve. Let's look at a couple more examples before this video gets way too old. So basically from here on out, we're just going to give you several formulas and ask you to solve for a particular variable. Take a look at this one. It says m minus n equals 5, and they say solve for m. So I'm going to write that m minus n equals 5. I want to end up with m equals. That's the one I'm trying to solve for, so I need an inverse operation. They did minus n, so I'm going to do plus n to both sides, like we always have. These guys, as you know, cancel out. That leaves me with m equals, which is great. That's what I was looking for. And I have to figure out what 5 plus n is. I don't know what 5 plus n is, but I can write it down. And there's, I have solved for m. Piece of cake. So this is going to be the last one for the video. Here we have the equation m over k equals x, and they want us to solve for k. Okay, now this one's kind of a stinker. There's a couple of different ways to handle this, but let's write it down first, and I'll show you the one that I like the best. M over k equals x. K's in a funny position. It's on the bottom of this fraction, but it is on the correct side. At least it looks like it is. One way we can attack problems like this is to imagine this as a proportion. Remember when we were solving proportions earlier? So instead of m over k equals x, I can make it m over k equals x over 1. And when you see it like this, you know that we can use cross products to solve. So I can actually do x times k, which is kx. And I can do m times 1, which is m. And I can use cross products to straighten that thing out. Either way, I end up with a new equation, which is kx equals m, and you can see that k, which is the thing I'm solving for, has been multiplied by x, so the inverse operation will be to divide by x. That's good news, because these x's turn to 1, they cross out. I end up with just k equals, which is what I wanted. And then on this side, oh my goodness, what is m divided by x? It doesn't matter. Turns out I'm just going to write it down, m over x. So when you solve for k, you end up with k equals m over x. And just remember that we did this little trick where we turned this thing into a proportion just by putting the x over 1, and we were able to use cross products. Made that problem a little easier to attack. Okay, I hope this gives you an idea of what we mean when we say solving for a variable. Basically, we're just using inverse operations to rearrange these things. We're going to have some problems to work on, and of course, if you have questions, we can address those as they come up. Good luck on this, and we'll see you soon.